Hello everyone, this is Ajay and you are welcome on my YouTube channel which is Math Cafe. This one is the part third of this topic which is matrix. So this video is all about algebra of matrices. Alright. So first one is equality. Two matrices A and B are said to be equal if they are of same order and their corresponding element should be same. If they are of same order and their corresponding element should be same. All right. If I am representing a matrix A by Aij of order m cross n, and another matrix B is represented by Bij of order, let's say, p cross q. If these two matrices A and B are said to be equal, then there are 2 points that first one is their order should be same. Their order should be same. That means number of rows should be equals to number of rows. That means m equal to p. And second one, number of columns should be same. That means n should be equal to q. And the second point is element should be same. Their corresponding elements should be same. That means all the elements Aij should be equal to Bij. Aij equal to Bij. Alright. These 2 points we need to remember if we are saying two matrices A and B are to be same. So let's take an example here. If a matrix is represented by, let's say, x, 3, 2 and y minus 4. Another matrix B is represented by 3, 3, 2 and x plus 2. If I am saying that both the matrices are same, alright, if A equal to B, then find values of x and y. Alright. So first of all, these two matrices A and B are said to be equal if their order is same. So the order of this matrix is 2 cross 2 and order of this matrix B is also 2 cross 2. So in these two matrices, order is same. Then another point is their element should be same. So their corresponding element should be same. So A11 equal to B11, A12 equal to B12, A13 equal to B13 and A21 equal to B21 and A22 equal to B22. Alright. So if I am saying that A equal to B, that means matrix x 2, 3, y minus 4, that is A, is said to be equal with matrix 3, 3, 2 and x plus 2, that is matrix B. Then their corresponding element should be same. That means A11 should be equal to B11. So we can deduce that x should be equal to 3 if these two matrices are same. And here 2 equal to 2 and 3 is already equal to 3. Then we will write that y minus 4 should be equal to x plus 2. So another equation is y minus 4 equal to x plus 2. So value of x is 3. We will put value of x equal to 3 in this equation. So 3 plus 2. then y minus 4 will become 5, and finally we will get the value of y as 9. So if A and B are said to be equal matrices, then x should be equal to 3 and y should be equal to 9. Hope you understand this. Let's take another example. If a matrix A is, let's say, x minus 2, y and 5, and another matrix B is equal to, let's say, 4, x minus 3, and let's say 2 plus y. Alright, if A equal to B, this is given in the question, then we need to find values of x and y. Alright, let's proceed with the solutions. So if A equal to B is given in the question, that means their order should be same. If both the matrices are same or equal, then their order should be same. So order of first matrix is 3 cross 1. There are 3 rows and 1 column, and order of the matrix B is also 3 cross 1. So first one is satisfying here, and second point is we need to equal all the corresponding elements. So we will write matrix A as x minus 2, y and 5 equal to, and B matrix is 4, x minus 3 and 2 plus y. So we will get here 3 equations. First equation is x minus 2 should be equal to 4, all the corresponding elements should be same, and second equation will be y will be equal to x minus 3, y is equal to x minus 3, and third equation we will get 5 equals to 2 plus y. So from the first equation we will get value of x, that is 6, and from the last equation we will get value of y, that is 3, and the value of x and y will satisfy the second equation also. If I put value of y as 3 and value of x is 6, so 3 equals to 6 minus 3, that means 3 equal to 3. Alright, so in this question we will get the value of x equals to 6 and value of y is equal to 3. Hope you understand this. Second algebra of matrices will be addition. Alright, in this part we will add two matrices A and B. If A is of order, let's say A is represented by Aij of order m cross n, and another matrix B is, let's say, this is represented by Bij of same order m cross n, then we can add both the matrices. Alright, so A plus B will become Aij plus Bij. So we will add all the corresponding elements of matrices A and B, and the order of A plus B would be same as m cross n. Alright, so let's take an example here. If a matrix A is, let's say, 2, 3, 5 and 2, another matrix B is 0, 1, 3, 4, and we are going to add both the matrices. We need to obtain in this question A plus B. Alright, so we are going to add A plus B. So first matrix A is 2, 3, 5, 2. Another matrix B is 0, 3, 1 and 4. If we need to add both the matrices, then their order should be same. Yes, and we will add all the corresponding elements. That means 2 will be added by 0. So that will become 2 plus 0, and another element will be 3 plus 3. So 3 will be added by 3, and 5 will be added by 1. So another element will be 5 plus 1, and the last element will be 2 plus 4. So this is A plus B, and I can write it as 2 plus 0, that will become 2, 6, 6 and 6. So that is A plus B. All right, hope you understand this. Okay, so third part of algebra of matrix is subtraction. All right, this is same as addition if a matrix A is represented by Aij of order m cross n. Another matrix B is represented by Bij of the same order m cross n. Then we can find A minus B by subtracting all the corresponding elements from A to B. All right, so we will obtain A minus B as Aij minus Bij, and order of the A minus B matrix will be same as m cross n. All right, and if we need to find B minus A, then we will subtract all the elements of Aij in Bij, so that will become Bij minus Aij, and order will be same. All right, so let's take an example here. If a matrix A is represented by 2 3 5 4, and another matrix B is represented by 3 0 minus 1 2, and we need to find A minus B. So how will we get A minus B? We are going to subtract matrix B from matrix A. So I am going to write A minus B. That means first A matrix is 3 3 5 and 4, and another matrix B we need to subtract from A, that is 3 0 minus 1 and 2. So we are going to subtract corresponding elements from A to B. So first element will be 3 minus of 3, 3 minus of 3. All right, second element will be 3 minus 0, 3 minus 0, and here 5 minus of minus 1, that will become 5 plus 1, and last element will be 4 minus 2, 4 minus 2. So we can easily obtain A minus B as 3 minus 3 will become 0, that will become 3, that will become 6, and that is nothing but 2. So that is A minus B matrix. So next we will see some properties based on summation and subtraction of two matrices. So there are some properties based on addition and subtraction. So first property is any matrix A plus B can be represented by B plus A. All right, so this law is called commutative law. Or commutative rule. And second property is if any matrix is represented by A plus B then plus C. If we are adding A plus B in matrix C, this can be expressed as A plus B plus C. All right, so this rule is called associative law. All right, so third rule is if any matrix A is added by any zero matrix, that is O, then this will become the matrix same as A, and that will be equal to any matrix 0 added by the same matrix A. And the fourth property is if any two matrices A plus B, if sum of any two matrices is 0, then A and B are called additive inverse of each other. Then A and B are additive inverse of each other. All right, if we have been given a matrix A, then we need to find its additive inverse, then that will become minus A. All right, and the fifth property is trace of A plus B will be trace of A plus trace of B. Alright, we can understand the point 5 by taking an example. Let's take an example here. If I'm writing a matrix A is 1 2 0 1 and another matrix B is 2 1 0 3, so we can find trace of A. Trace of A will be sum of all the diagonal elements, that will 1 plus 1, that will become 2. And trace of B we can easily obtain by adding all the diagonal elements. So 2 plus 3, that will become 5. So here trace of A is 2 and trace of B is 5. If we are adding both the matrices, then A plus B will become 1 2 0 1 plus 2 1 0 3. Alright, so we will add corresponding elements to get A plus B. So 1 plus 2, that is 3, 2 plus 0, that is 2, 0 plus 1, that is 1, and 1 plus 3, that is 4. So A plus B will become this matrix. So we can find trace of A plus B by adding all the diagonal elements. 3 plus 4, that will become 7. I can easily see here that trace of A plus B, that is 7, and that is equal to trace of A plus trace of B, because trace of A plus B is 7 and trace of A is 2 and trace of B is 5. So here 7 equal to 7. 7 is equal to 7. Alright, so we have seen 5 points on properties. Let's take another point, that is point number 6. Alright, so point number 6 is, if we are finding A minus B, that will be not equal to B minus A. Okay, in general. If we are taking A and B as 0 matrices, then this will be equal. Alright, so in general A minus B will not be equal to B minus A. Alright, let's take another point 7. Determinant value of A plus B will not be equal to determinant value of A plus determinant value of B, also in general. So this can be equal in some cases, but in general these two terms will not be equal. So next point is multiplication of matrix. By a scalar. That is point number 4. So that is another part of algebra of matrices, multiplication of a matrix by a scalar. If a matrix A is, let's take a matrix A. If a matrix A is 1, 2, 3 and 4. If we need to obtain the value of 3A, how will I get this value? I am going to multiply 3 by each of the elements. So by multiplying each of the elements, 3 multiplied by 2, 3 multiplied by 3 and 3 multiplied by 4. Alright, so 3A will become 3, 6, 9 and 12. Alright, so if we are multiplying any matrix by a scalar, then scalar quantity will be multiplied by each of the elements. Alright, so let's see some properties based on multiplication of matrix by a scalar. So in each of the properties, we will take a matrix A of order n cross n. So first property is determinant value of Ka will be equal to k raised to n and determinant value of A. So if a matrix having order n, then determinant value of Ka will be equal to k raised to n determinant value of A. Alright, so let's take an example here. If a matrix of order 2 cross 2 is given, matrix determinant value of this matrix is 2, then we need to find the value of 3. All right, let's see how we will solve it. So I can take 3 out of this determinant value, so that will become 3 raised to n. N is number of order of matrix, that is 2. So order of matrix is 2, and we will left with only determinant a. So here 3 square multiplied by determinant of a, and value of determinant a is given in the question 2. So that will become 9 multiplied by 2. Final answer will be 18. Alright, hope you understand this. Let's take another example. Alright, if we have been given that a determinant value of order 3 cross 3 is, let's say, -1, then we need to find -5a. Alright, let's proceed with the solutions. So -5a, I can take -5 out of this determinant value, that will become -5 raised to n. N is order of this matrix A. So order of this matrix A is 3. So I will put 3 in the power of -5, and the left quantity is determinant of A. So -5 power 3 multiplied by determinant of A. Determinant of A is -1. So finally that will become -125 multiplied by -1. Final value will be +125. Let's move to the property number 2. Trace of Ka. Alright, if any matrix A is multiplied by scalar quantity K, then trace of Ka will become K times of trace of A. Alright, so let's take an example here. If any matrix A is, let's say, A, B, C and D. So here trace of A is sum of all the diagonal elements, that is A plus B, A plus D. Alright, so Ka will become, I'm going to multiply K by each of the elements. So here Ka, Kb, Kc and Kd. If I'm going to find trace of Ka, that will become Ka plus Kd, Ka plus Kd. Alright, so here trace of Ka is Ka plus Kd. I'm going to take common K, A plus D, and A plus D is trace of A. So that will become K times of trace of A. So that is what we need to find. That is property number 2, and let's take property number 3. If K1 is multiplied by A and K2 is multiplied by A, then that will become K1 plus K2 multiplied by A. And the fourth property is, if Ka is added by another matrix Kb, then that will become K times of A plus B. Alright, and the fifth property is, if Ka equal to Kb, then there are 2 points. First one is A can be equal to B. Alright, and second one is K can be equal to 0. So let's take an example here. Let's say if any matrix A is represented by 1, 2, 0, -2, 1, 3, 0, -1, 2. Alright, and another matrix B is represented by 1, 2, 0, -2, 3, 1, 2, 1, 0. Then we need to obtain the value of 2a plus 3b minus 5i3. Alright, so let's proceed with the solutions. We need to find the value of 2 times of a plus 3 times of b minus 5 times of i3. Alright, so first of all I will multiply any matrix A by scalar quantity 2. So how will we get 2a? 2 times of A matrix is 1 2 0 minus 2 1 3 0 minus 1 2. All right, plus 3 times of matrix B, that is 1 minus 2 2 2 3 1 0 1 0. You see here, actually order of both the matrices are same. All right, and we are subtracting 5 times of I3. I3 is identity matrix of order 3, that is 1 0 0 0 1 0 and 0 0 1. All right, so I am going to multiply 2 by each of the elements. So here 2a will become 2 4 0 minus 4 2 6 0 minus 2 4. All right, and 3b will become 3 minus 6 6 6 9 3 0 3 0. All right, and minus 5 I3 will become 5 0 0 0 5 0 and 0 0 5. I'm going to add or subtract each of the corresponding elements. So the whole matrix will become 2 plus 3 minus 5. So first element will be 2 plus 3 minus 5, and second element will be 4 minus 6 minus 0, and third element will be 0 plus 6 minus 0. All right, so we are complete with row number 1, and first element of second row will be minus 4 plus 6 minus 0, minus 4 plus 6 minus 0, and another element will be 2 plus 9 minus 5, and the last element of second row will be 6 plus 3 minus 0. All right, and the first element of third row will be 0 plus 0 minus 0, and then minus 2 plus 3 minus 0, then 4 plus 0 minus 5. All right, let's solve it. 2 plus 3 5, 5 minus 5 will become 0. 4 minus 6 minus 2, minus 2 minus 0 minus 2. 0 plus 6 minus 0, that will become 6, and minus 4 plus 6 is 2. 9 plus 2 11, 11 minus 5 is 6. 6 plus 3 is 9, and that is 0, and minus 2 plus 3 is 1. 4 minus 5 is minus 1. So that is our final answer. If it is given in the question that x plus y is a matrix 2 cross order of 2 cross 2, 2 3 minus 2 1. All right, and another matrix 2x is given, let's say 2 0 4 6. All right, and we need to find the value of x and y. So we are going to find the value of x and y with the help of summation of two matrices and subtraction of two matrices. All right, so here 2x is given to us as 2 4 0 and 6. I can find x by dividing 2, so that will become 1 by 2 of 2 4 0 and 6. So I'm going to multiply this matrix by 1 by 2. So 1 by 2 will be multiplied by each of elements. So x will become 2 by 2, that will become 1, 4 by 2, that is 2, 0 by 2, that is 0, and 6 by 2, that is 3. So we have obtained the value of x. All right, so I'm going to put the value of x in equation this. Let's say this is equation number 1 and this is equation number 2. All right, from equation number 1, so in the equation number 1, it is given that x plus y is equal to 2 3 minus 2 1. All right, and how will we get the value of y here? Y will be equal to 2 3 minus 2 1 minus x. and we have already the value of x. So y will be equal to 2, 3, minus 2, 1, minus another matrix x, which is 1, 0, 2, 3. So this is subtraction of two matrices. So I'm going to subtract each of the corresponding elements. So y will become 2 minus 1, minus 2 minus 2, 3 minus 0, and 1 minus 3. So finally y will become 1 minus 4, 3 minus 2. Alright. So we have found out the value of x as well as y in the given problem. Hope you understand this lecture. If you still have any doubt, you may ask in the comment section. See you soon in the next video. Till then, bye, take care and keep learning.